Welcome back to Engineering Acoustics. Hi, this is Professor Ryan Harne. In this video, we'll learn about how we characterize the ease with which people communicate in rooms according to speech intelligibility.
So let's get started. Interference to people's communication results in frustration, irritation, anxiety, stress, disadvantage between people, and many other socioeconomic impacts. And people speak all day, and they speak at similar levels throughout the day. So there are a wide variety of social norms and expectations for how loud the background noises in work or at home are acceptable to be able to speak clearly. So in the classroom, we might expect a very low background noise level, so a teacher can speak to her students. But in an open office environment, there might naturally be more background noise from other conversations, so we would expect and we might need to speak slightly more loudly to be heard. Engineers, as a result, need a metric to anticipate how much background environmental noise is permissible to affect speech intelligibility. Speech interference level, the SIL, therefore quantifies the noise levels that most interfere with communication. The SIL is an average of the background noise octave band SPO readings in dB from 500 Hz to 4 kHz. The SIL is used in a wide variety of noise regulation recommendations and guidelines since it is closely related to our subjective perception of how challenging it is to listen over noise. The SIL varies by distance between the source and receiver. Of course, sounds radiate spherically in the environment, so that the distance of propagation of the sound from source to receiver is very important to consider in this fact. The speech interference level also influences the necessary voice level for the listener to receive at least 95% of the message. So let's consider this table. On the left, we'll have a column of distance between the talker and the listener. The speech interference level will be given in the rows. And up top is the relationship between the voice level required to be heard over the given speech interference level. Now, when we're just about 6 inches away from our listener, we could have a very loud background noise environment and still be able to speak at a normal voice level. So the background noise level in terms of SIL could be 71 decibels, and we still would only need a normal voice level to be heard. Let's consider the rest of this plot. If we go out to 3 feet distant between source and receiver, the background noise level could only be 55 decibels for us to use a normal voice to be heard. Otherwise, if the background noise level increased to 73 decibels, we would have to literally shout to be heard at just 3 feet away. If we double that distance, we find that the speech interference levels that are permissible for the same voice levels all drop by 6 dB, since we have doubled our distance, and according to spherical sound radiation, we have a 6 dB drop from source to receiver. So a normal voice level would require no more than 49 decibels in background noise, while a shouting voice would require no more than 67 decibels to be heard, at least for 95% of the message. What's important to recognize here is that in general, for normal conversation over moderate distances, these background noise levels need to be quite low for hearing to occur. SIL, the speech interference level, is also closely tied to the lead standard. SIL is included in the ANSI S12.60 standard, and this must be met for a building to achieve Leadership in Energy and Environmental Design certification from the U.S. Green Building Council, the LEED certification. And buildings that meet LEED earn tax credits, which is the motivation for meeting this certification, so that their capital investment in the facility leads to longer-term tax benefits. LEED includes other acoustic regulations that we won't mention here, such as reverberation time, noise insulation, and so on. But speech interference level, given that it is closely tied to subjective ease of communicating, is an integral part of the LEED standard. So let's summarize what we've learned. The speech interference level associates background noise with the challenge to communicate in a given space. Recommendations show how the background noise must be contained in order for intelligible communication to occur without aggravating speakers or listeners. Acoustic metrics are steadily finding their way into U.S. certifications, and this helps to create home, office, business, and community spaces that promote better societal well-being.
That's it for this video. In the next video, we'll learn how these sounds that build up in rooms are determined to be appropriate for one or another use, according to yet another sound level metric.